Hey, everybody. So this is a continuation of worksheet 5. So again, I kind of gave you some information before as you were working on it, worked with you a little bit as you went through, and then had you do some stuff on your own. So hopefully now, after you've made an attempt on this whole thing, you can look back at this and kind of see what you should or shouldn't have seen with these questions and the answers that go with them. So let's see. So we had the hydrogen that was sharing with another hydrogen. And what have they done to fill the first electron energy level, which I had said the other day? They're sharing one pair of electrons between them. And then so the dot diagram for H2O had a shared pair between each of the two, which would be a single covalent bond is what we call that, because it's sharing a single pair. They're each contributing a single pair or a single electron to make a pair that they share. So circle the shared pairs. Okay, we did that. Draw a dot diagram for a carbon atom. Oh, I think I need to move my. Oh no, hold on. I got to get this. Oh, geez. Hold on. Let me put me over here, and then I will click this, and then this, and then that. Okay. Oh, line. Oh no. Did I do the line? Oh, I'm in the way again. I tell you. Oh my gosh, and I gotta click back on this. Oh. There we go. Okay. Now, I think I can. Oh, geez. Oh my gosh. What is happening right now? Okay. Man, I tell you what, rough day, rough start. So, dot diagram of carbon. All right, so carbon, hopefully you had something drawn like this where there's a dot here, dot here, dot here, and dot here, which, again, there's 4 dots because carbon has a valence number of 4, which, again, you can see on the periodic table, right? So remember, all those things we learned before, you still need to know them, like valence number, especially, see, for ionic bonding, the oxidation number is critical. For covalent bonding, the valence number is what's critical. Okay, so we have to start with the dot diagram. So the valence number is important, and then we see where all the empty spots are, which again is the next question after you get the chlorine sketch done. So for chlorine, hopefully you can look at the table and see that chlorine is a what for valence? 7. 1, 2, 3, 4, 5, 6, and 7. Now, the next 2 questions were how many empty spots, missing electrons are there, empty spots for the carbon and for the chlorine. So carbon has only 4 valence electrons, which means there's 4 spots where another electron needs to be. Because remember, the whole goal here, whether it be through ionic bonding or through covalent bonding, is that these atoms are trying to complete an octet. They want an octet. And so the carbon atom needs 4 more. There's 4 spots where 4 more electrons need to go. The chlorine atom only has 1 empty spot. There's only 1 place where an electron needs to be to complete the octet. I should say someone else's electron needs to be. There's only 1 place. And so that's, again, 4 for carbon and then 1 for chlorine. Then we move on to the next page. If I can get the next page going here. Using the molecular models, construct the molecule of carbon and chlorine, which I did so that all the missing spots are filled. And so, again, the missing spots for the carbon, again, they're actually holes. So this thing has holes in the center one, the black one, which is carbon, which is why there's 4 sticks coming out of it because there's 4 holes, 4 empty spots. So we occupy the empty spots with a stick, and that stick then is connecting each of these chlorines here, which again I had showed you the other day. All right. So how many carbon atoms are in the molecule? Well, hopefully you can see that there's only one. There's one. Oh gosh. There's 1 carbon atom in the molecule. How many chlorine atoms are in the molecule? 4. Then you're supposed to sketch a dot diagram. What would the dot diagram look like for that? Okay, to have 1 carbon in the middle surrounded by chlorines, how would you construct a dot diagram for that to work? Here's the deal. Let's go orange first for carbon. So carbon has, again, the 1 and the 2 and the 3 and the 4. Now, for a chlorine atom to be around the carbon, you have a chlorine here. 1, 2, 3, 4. There's already 1 there. 5, 6, 7. Now, do you see what happened here? That chlorine, the empty spot on the chlorine goes up and occupies the empty spot of carbon. So they're each filling each other's empty spot. So what do you see around chlorine, this chlorine atom right now? There's 2, 4, 6, 8. It has 8. One of the carbon electrons is filling one of, or I should say, the only empty spot in chlorine. And that chlorine atom is filling 1 of the 4 empty spots for carbon. So do you see how this could continue? And 3 more chlorines could go in and do the same thing. So another one over here. Oh, I changed it to a pointer. What's happening here? So chlorine here with 1, 2, 3, 4, 5, 6, 7. Then another chlorine up top. Oh boy. Oh no. Another chlorine up here where there's 1, 2, 3. Oh no. 4, 5. This is not working well. 6, 7. And another chlorine over here where there's 1, 2, 3, 4, 5, 6, 7. So for this, it's kind of a mess here. But do you see how it's going? I'm about to spill my coffee. Oh my gosh. So for this molecule here, we have each chlorine with 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. And 2, 4, 6, 8. Each chlorine has 8 electrons around it. That's an octet. They're happy. The carbon now has 2, 4, 6, and 8. They have a shared pair between each pair of atoms. Okay? So this is the dot diagram that represents this little thing here. Okay, this is what's happening. Now it says circle the shared pairs in the dot diagram. Okay, let's circle those. Let's get a different color here. Let's go with, maybe. Let's go. So there's a shared pair. There's a shared pair. There's a shared pair. There's a shared pair. So we have 4 shared pairs. How many shared pairs? 4. 4 shared pairs. Now, how many sticks were used in the molecule you built? How many sticks? Look at the molecule. How many sticks is that? Do you see that? There's 4 sticks. Yeah? 4. Oh, I almost said 3. 4 sticks. Okay, how many sticks? They're not wooden, they're actually plastic. So there's 4 sticks. Now, what do you think these sticks represent? If we have 4 shared pairs in the diagram and we have 4 sticks in the model, then that means each stick represents a shared pair, right? They each represent a shared pair. A shared pair, shared pair of electrons. Okay, which is, and I'm going to put on here, and you should probably add this, what we call a single covalent bond. That's what a single covalent bond is. When you share a single pair, which means, since I'm bringing that up, that means there can be more than just one pair that's shared between each atom. Now, we won't get into any of those, but that is, there's more than one kind of covalent bond. We're only going to deal with single bonds because they're the simplest and easiest. It's like putting together puzzle pieces, okay? If you haven't figured that out yet, this is like little puzzle pieces. The empty spot pairs with the empty spot, or I should say the electron, the single electron on one side of a dot diagram pairs with the other single electron on another atom's dot diagram. And again, it's like puzzle pieces. So draw a dot diagram below for a sulfur atom. Okay, so moving on. So now we have sulfur, which you're supposed to be able to find in the table, which has how many electrons around it? 1, 2, 3, 4, 5, and 6. Because remember, the valence number for sulfur is 6. Hopefully you looked that up if you didn't remember it. And then you're supposed to draw a dot diagram for fluorine atom, which is in the same family as chlorine that we just had. It's a halogen. And so that is a 7, remember, 1, 2, 3, 4, 5, 6, and 7. And so using the molecular models, construct a molecule for sulfur and fluorine atoms so that all the missing electrons have shared pairs, or empty spots get filled. So, molecular models. First we have to locate which one of these things is which. Okay, now I happen to have this one right here. This orange one has a single hole, right? Single hole in it. And so which one would this be? Which of the two, sulfur or fluorine, which would be like this? I hope you're thinking fluorine, because it has a single empty spot. And so we have a single hole here. Now, this one here has 1 and then 2. There are 2 holes in this little ball here. And so the fact that there are 2 holes here, that would be similar to what? Sulfur, which has 2 empty spots. Yeah? So how can we make one with 2 holes here? Oh, where are they? There. Oh, there. You can kind of right there. How do we get one with 2 holes in it to pair up? Oh my gosh, with only 1 hole in it? Well, we take some sticks here and put one stick in one hole, and then the one here, and then I put another one here, and this one, and then another one here. And so now one stick is longer than the other. There's no necessarily reason for that. But that is what we get, right? And so that means there's a single sulfur, and then there's 2 of the what? Fluorines, right? 2 fluorines. Oh my gosh, it fell apart. So 2 fluorines, 1 sulfur. That's the only way we can get all the empty spots filled with the models, okay? And so now you're supposed to construct a dot diagram with these two here. That means, let's go back to green here. Back to green. Oh my gosh, this thing is acting nuts. Oh my goodness gracious. This thing gets, okay. Sulfur, 1, 2, 3, 4, 5, and 6. And so that means one fluorine, one fluorine could be down here where we have 1, 2, 3, 4, 5, 6, 7. So that makes an octet. And then we have another fluorine over here where we have 1, 2, 3, 4, 5, 6, 7. Now, if you'll notice then, this fluorine has 2, 4, 6, 8 around it. This fluorine has 2, 4, 6, 8 around it. Sulfur now has 2, 4, 6, 8 around it. Everybody's happy. Everybody has an octet. Okay? In your dot diagrams for covalent bonding like this, you're always going to see an octet around each atom. If you don't, then there's a problem. Right? If you do not see an octet around each atom, then we have a problem. Right? There has to be an octet. So hopefully this made sense. If it didn't before, I hope you see it now. It's literally like plugging these in. If I can take this and just stick it right there like that, where the opposites, each electron come in as a shared pair like a puzzle piece, and this one goes up here like that. So again, if you can hopefully envision this like puzzle pieces, easy to go in there, easy does it here. What I hope is this. Because of what these look like, chlorine being a halogen and having only one empty spot, and fluorine, again, being a halogen and having only one empty spot, those are so easy to use in covalent bonding, because if they only have a single empty spot, they can plug in easily anywhere there is an empty spot. So it makes the halogens with a valence number of 7, it makes them very easy to use to demonstrate how these molecules can kind of plug in and fit together. All right. Hydrogen is another one. Let's see if I go back to the previous slide. Hydrogen is another one that works really well, because all you need is a single empty spot, and hydrogen can also plug in and get an octet. Now remember, with hydrogen, the octet is only a double. It's a full first level. So having a pair makes hydrogen have an octet. So that's handy as well. So between hydrogen and the halogens, those are going to probably be used in most of our examples here that we have to build and construct, because they're so simple. Okay, they're so easy to use because they have one empty spot and can plug in anywhere. So I hope that that made sense, and that maybe if you were confused before, hopefully that cleared things up. So, hey, I will see you all then next week, and take care of yourselves until we meet again. Over and out.